Rustlang Meetup Malaysia. So this will be the last online meetup that we have for the year. And for the next Rust Meetup in January, for the next meetup in January, there will be we'll switch it back to offline. So this will be the last online meetup. So today there will be a couple of lightning talks. One will be given. So the first speaker will be Steele. He's from Rust DC, a friend from Rust DC in US. And then the next speaker will be Chee Chyuan from eth.kl, and then Raj, and the last speaker will be Alan from the Rust station. Yeah. So let's welcome Scott to give the first talk. Yeah, Scott.
Cool. Thanks. Let's see. Yes, go live. All right. Can everyone see that? Yes? No? Okay, cool. Thanks. All right. So I'm going to be talking about knots. Not so much like something that's very specific to Rust, but just a recent project I was working on in knots. So I don't know if anyone here is familiar with like the mathematical knot. Is anyone here familiar with that? Raised hands. Okay. So I'll briefly, hopefully, say what those are. This is the simplest one you can get. It's the unknot. We're talking about knots that like if you take a piece of string and then loop it back on itself and attach it, and then you're not allowed at that point to like cut it and reattach. So that's the kind of knot we're talking about. The simplest one is the unknot, right? It's just a simple loop. The next simplest one that isn't the trivial unknot is the trefoil. I think I hope this makes intuitive sense. It was something I studied in undergrad, and it was kind of fun because you end up, instead of spending a lot of time calculating things, you do some calculations as you go. But a lot of what you do is drawing these little diagrams, especially earlier on in the class, which is kind of cool. And this is another one. This is a square figure 8 knot. I won't show any more complex ones than this, but right, they can obviously get there's no limit to how complicated they can get, obviously. So I hope that kind of makes sense as a concept. And so then what you are often doing once you have these diagrams is you are trying to figure out like, how can I manipulate the diagram in such a way that I don't ever break the string, right? So I can do things to the diagram like pull, the blue means under, red is going to mean over for a lot of this. So I could pull something in the back, I could pull it down under the front, right? Like that, right? So I haven't changed the logical knot there, even though I'm making substantial changes to the diagram. Here I'm pulling up and twisting. So the red again is going over. So I've pulled up and twisted. And now I'm going to pull that lower part all the way up behind everything to there. And now you can see that's very close to the trefoil that we looked at earlier. But there's one thing missing. That crossing, the only way to get back to the trefoil is to do a change that in this case actually does affect the logical knot that we're working with. So this is like, you make careful note of when you are making a crossing change, because now you are possibly changing the knot. So if you said, hey, I'm going to make a crossing change, I'm going to cut the string, move it forward, and reattach it, then you would get back to the trefoil. So that like introduces, like that's a lot of what the first couple weeks of undergrad knot theory class are. You care about some things like the number of crossings that show up, that unknotting number, right? Since I was able to go from the unknot to the trefoil with only one crossing change, the trefoil has an unknotting number of 1. And then that like series of things that we did with the unknot it's like a specific case of what you're doing in the more general case where you were looking at equivalences of knots. So I think it makes sense that, right, again, if I pull this part up to the right and twist, right, I still have a trefoil there, but now I have 4 crossings. And so the diagram has changed, but the logical knot hasn't changed. And so as you can get more and more complicated diagrams, like one of the things you often end up needing to do is saying like, hey, I drew a diagram with like 1,000 crossings in it. Is that like a new knot that, you know, has to have 1,000 crossings? Or is it just a really complicated version of the trefoil, or, you know, a knot that has 11 crossings in its minimal diagram, or so on? Yep, it's still a trefoil. So there are a couple of moves, and I'll try it. Yeah, there are a couple of moves that a dude named Reidemeister came up with. So there's already like these definitions of like, okay, here are things you can do that do like kind of change the crossings, but you still have the same things. You go left or right, and those are going to be the same. Same for that, right? Pull the top one over. That one's a little more interesting. It's right, like if you have 2 and 3 are crossing each other and 1 is going between them, you can move that one from the right over to the left. But so those are just some examples. And then there's like quote unquote kind of Reidemeister 0, which is basically, yeah, anything that doesn't involve changing the crossings, you can just go ahead and do, right? Like adding, removing bulges, sliding crossings along other strands, as long as you're not running into other crossings. So there were some like fun questions from undergrad that I always kind of wanted to like, how would I work on this with a computer? Because like some of this could definitely benefit by a little bit of brute force labor, but like spatial representations of knots would be really kind of gnarly to work with, because now you're doing like physics simulations basically just to do the knot. And then there are some other properties that it has that like don't fully describe the diagram, and so like there are a lot of limits to what you can use with some of the other properties. I won't go into them at all, but maybe you could do something like that with a proof assistant. But I also have no experience with proof assistants, and every tutorial has been not super great. Quick aside, this was like heavily catalyzed by Dave and Felipe's Hatris blog and talk. So in that, they focused a lot on how they got a decent encoding for solving Tetris or getting high scores in Hatris. So I'm going to try to move quickly on this, but like basically the thing that was interesting and that I picked up in the last couple of weeks was like, okay, what's an encoding for these diagrams that is relatively simple, succinct, but lets me know how I can operate on them in a way that preserves the knot. So I used friends, forward and backslashes to represent like these openings and closings, and then the slashes to represent like going over or under with respect to the lower strand. And then the number is the vertical index. Like if you were drawing a line from left to right, or moving your line from left to right, your vertical line, like when would you get to the, how many strands would you have to get to the element that you're addressing? So that ends up working. And then like stuff like the Reidemeister 1, so Reit is short for Reidemeister, where you're doing a flip, we say like, okay, we want to do it over, and we want to do it at horizontal index 0. So starting at the very beginning where we have that opening, all it ends up doing is just, right, like you see what happened in the diagram where you pulled over to the left and twisted, but the operation on the encoding is like incredibly simple, right? We just insert an over crossing at the vertical 0 index. So now, let's see how quickly this will let me switch my screen share. Hopefully really fast. That's what I'm hoping. Change windows. Yes. Okay, cool. Yes, go live, please. Okay, cool. So this is, if you go to the link that I shared with Ivan, which I don't know if he shared, but if you download that, so this is the Rust project that I've been working on, and this is the WebAssembly version of it. So as we go across the horizontal indices, we can add these knots and get our trefoil. I have these all pre-commented out so I can just do it quickly. But here's the thing is then kind of fun, is like, okay, so I am going to do one crossing change. So I'm going to cross at index 0, 1, 2. I'm going to change this crossing. So I've now changed that one. I do a Reidemeister 3 to move this one back here down. This, I have to do these swaps that are inherent to my encoding. So it might be a weakness of the encoding, but I need to move this over so that I know it's adjacent. And then that one's adjacent. And now I have this big pull and twist one up top that I can get rid of. So I do a Reidemeister 1. There are two kinds of this twist. I do a 1B reduce at index 2. So 0, 1, 2, that index there. And now I have this standard like Reidemeister 2, like one strand going over another strand. Thing that was kind of cool to get working because, and I'll switch back. Share your screen. Change windows. Yes. So much. Yes. Go live. Okay, cool. Because in college, like I was doing this with like pen and paper. Pencil didn't work very well because it was too like smeary, and then you couldn't make out the crossings anymore. And so like there's a lot of like redrawing diagrams and then not being sure if you drew them correctly and having to go back and draw them again. And this would have been useful, like to just be able to very quickly like, no wait, like try doing that thing. All right, now move back. And then the other thing that is like, I may try to do more with is that again, like the most number of those horizontal indices that you need to look at is 3 to be able to tell if a move is legal. Most of them are actually like 2 or 1. So you can make conclusions just by looking at a very tiny subset of the diagram of moves that are legal to make, which then may make that more interesting to play with automated learning on how to simplify the knots. So a couple big caveats. So this was me on the left in undergrad, and over time I grew more whiskers and wrinkles. And something that happens if you zoom in to whiskers and wrinkles is like really cool things that you would otherwise see and be really impressed by and excited by. They get caught there and you don't see them. So there are like way better libraries for manipulating knots. I haven't looked at them enough to know like the trade-offs and whether my encoding has anything vaguely useful that they don't have. My guess would be not, that it doesn't, other than it's in Rust, and that's fun. We all love Rust. But so I hadn't been like checking on all of these cool things that have been developed in the meantime, and they are very cool. So yeah, like if I were taking a knot theory class today or just trying to play with them from scratch and wasn't interested in doing it in Rust, I'd probably use some of those tools. I also don't know what the consequences are of my tying encoding so directly to the diagram. Maybe it'll end up being bad. Maybe it'll end up being very useful. I'm not sure. But so caveats, schmaviats, who cares? It was really fun going through the encoding as an exercise. Has helped me like think about more about the problem of how you would automate like maybe train something to be better at automatically simplifying or complexifying a diagram. And regardless of whether I keep using my encoding or look at some of the other libraries. And also too, it was only like 3 or so weeks of investment. So not the end of the world if it ends up being awful. Really quick Rust notes. I hadn't done any WASM. I'd done some WASM development 2 years ago, 3 years ago, and 4 years ago. I hadn't done any for like 2 years. It's a lot better now. Like I thought there was a big improvement between like 4 and 2 years ago. There's been like, if you haven't done it in a while and you're like, oh man, it takes forever to compile and you end up having to use Nightly with a bunch of tooling. You don't have to do that anymore. It's really great. The framework, right, just recommends using trunk. So I'm sure everybody else here already knew that, but it was nice to return after not using it for a bit and find it was really great. U is still pretty cool, but they don't advertise themselves yet as being for real quote unquote production apps. But that's what I used here. I was pretty happy with it. It's nice for very quickly prototyping input-output changes. So yeah, that's that. Any questions? I'll share. I'll try to turn on my camera. Hopefully the bandwidth won't die. Derp, derp, derp.
So these all are done from the browser, right? Not like the desktop app.
Yeah. Oh, I forgot to mention. I also wanted to plug SVG Bob. If like it was a really big deal in like, I don't know, I feel like 4 years ago. Maybe it's not a big deal anymore. It was really useful because I just in that demo that I was showing, right, where you have the like ASCII version and then SVG version. SVG isn't super pretty, but like the way that I get the SVG version is just to dump that ASCII version string directly into SVG Bob, and then it generates that SVG. So that was really useful. Like if you're doing something like this where you're like, oh, I can probably make a table in ASCII, but I don't want to take a lot of time to make a, you know, like a slightly better SVG version, you may just be able to dump it into SVG Bob, which is a nice Rust project. Right, and then because of that, since it was already, like it integrated well with this, because it was just, oh, just pull in this Rust crate, and it does it for you. So, forgot to plug that. Cool. Any other questions?
You face any difficulties using Rust or anything with the knots?
Not with like for the knots, it was really great. I think if I were really concerned about using pre-existing libraries, I might have been bummed. But like a lot of the pre-existing libraries are much like I care more about just like playing with the diagrams, and like there's still unsolved problems with just these simple diagram questions. Like I haven't been reading up on all the stuff to be like, oh, like the whatever like topological covering that like gives you this particular invariant, right? Like I haven't been reading up all of that stuff, and like it looks like that's what I'm missing by maybe not using like a Python library or something. But I don't, at the moment, I don't worry too much about that. So I would say the thing that was most annoying is I'm still figuring out how to use U correctly, and it probably would have been a little bit faster if I could like to develop if I had. It was really fast to just like take the Rust code, dump it into U, and be able to like hook things up. But then when I was trying to like, for instance, I have a branch where I like, in addition to having the text boxes, it lists every possible move that you could do next. So you don't have to know to type it in. You can just click on the move. But like that ends up being a little unmanageable, and you need like some like, you know, input items and selectors and stuff. That started to get really difficult to do in U because it wasn't a common case. And I know it's doable, but just more time consuming.
And there are two more questions here. Is it not because of browser having better support now? The WASM is better now compared to a few years back.
Oh, no. The main reason that it's vastly better because the tooling is better. Like with some of the stuff I used maybe 2 or 3 years ago, you had to use nightly. And then the other, like the compilation speed was terrible. Like it took forever to compile, like a really long time to compile. And now it's like really, it's pretty snappy. Like it doesn't seem any longer than regular Rust compilation. Maybe even be marginally faster. I'm not sure. And then like the tool that I mentioned that that's right there, trunk. It has like some of the niceties that you expect from a slightly more modern like development tool, right? Like the auto reload and like auto page reload. Like that stuff wasn't available then. You would have to rebuild, and again, it took a really long time to rebuild. So those were the main reasons: rebuild speed and not having to use nightly.
Also, Conchon say, you mean it is WASM tooling, not the application running in a browser is better.
What's that?
Yeah, so you mean WASM tooling? Someone mentioned.
Yeah. It's the tooling outside of the browser that's a lot better than it was a couple years ago.
Okay, supposedly the times is up, but there's one last question. I'll just say, if using the same program in an older browser 3 years back, will it still run the same performance-wise and functionality-wise? Yeah, 3 years back.
A few years back, yeah.
No, 3 years back, like roughly.
I think probably 3 years back it would probably work. I would have, like, you're starting, like, I think it's like 4 or 5 years back where there were some like upgrade pains, I think. Yeah. Yeah, thank you.
Yeah, okay. Thank you, Scott, for your talk. So the next speaker will be Chee Chyuan.
Okay. Let me just turn on my screen and share my screen. Real quick. Yeah, I also want to make sure that if everyone can see. So I can't see the chat now. So if Ivan can probably can give me like a thumbs up or like a yes that you can see my screen, that would be nice.
Yeah, I can see your screen.
Fantastic. So yeah, good to go. So hi everyone, my name is Chee Chyuan. I'm from eth.kl. This is it's very it's not like technical as the one that you've seen by Scott, but yeah. So I wouldn't also delve in too deep into the blockchain ecosystem. I will probably give like an overview of how blockchain has evolved over the years, and at the end of the talk, I will go through a bit of how Golang and Rust is being used in the blockchain space. Yeah, but feel free to. I think there's a 5 minutes Q&A session, but over there you can probably ask questions that you want to know. But yeah, this is a very high level and very beginner friendly talk. So do not worry if you do not know blockchain. This is for you to understand. Again, I'm Chee Chyuan from eth.kl. eth.kl is a group. It's an Ethereum Malaysia community, and it's free for all for you to join. So if you are interested, I will share the link later after the talk. So yeah, without further ado, let's get started. So some history of blockchain. So the first practical blockchain we ever know, it's Bitcoin, and it is by the white paper by Satoshi Nakamoto. So he proposed a decentralized money system whereby everyone is in charge of the ownership of the money. So what I'm trying to say is that no one owns the system. Right? So unlike in a bank, whereby the bank basically takes your money and then you have to trust the bank that hey, your money is secured. And yeah, so in Bitcoin there's no such thing because everyone has the ability to be part of the system, and this is what we call permissionless. And Bitcoin, the sole purpose of having the Bitcoin blockchain, again, stress that Bitcoin and the blockchain is an entirely different thing. Bitcoin is a currency that is being transferred in the Bitcoin blockchain, and the blockchain itself is basically a huge decentralized piece of ledger that everyone can take part in and participate as a node or as a miner and so on and so forth. So again, the main responsibility of the blockchain is to facilitate the transferring of Bitcoin. And Bitcoin at a very long time, I think around 4 or 5, it's like 5, 6, 7 years ago. The main purpose of the blockchain is just to decentralize the money system in a way that everyone in the world is able to freely participate and take part in money, in finance. So that is the origin of blockchain and Bitcoin. And then it turns out that hey, the interest of blockchain really heats up, and a couple of years after Bitcoin, this guy called Vitalik and a bunch of very smart people proposed that hey, instead of just transferring money, we want to do more things than that. So they proposed this thing called the EVM, which is the Ethereum Virtual Machine. So what you can think of the Ethereum Virtual Machine is a computer. It's a global computer that is decentralized, meaning everyone is able to run the computation to make sure that it is the execution is being run correctly. And it's a VM, meaning that it has to be Turing complete, and because it is Turing complete, it allows a very almost unlimited programmability to the blockchain. And by using this thing called the smart contracts, we are able to write logics, piece of codes, deploy it on the blockchain, and we are able to execute it. And that really how can I say, facilitate another round of like hype over blockchain, because there are many creative use cases such as DAOs. DAOs are like decentralized autonomous organization, and DeFi and NFTs and all sort of like those fancy words that you may have here in the media or in the public. So it is because of the nature of the EVM that allows programmability in the blockchain. So yeah, so now we have moved from decentralizing money to decentralizing programmability, so to say. So that's the point that we are at now. And it turns out that because in the world of blockchain, whereby there are a lot of redundancy, whereby everyone in the world needs to re-execute re-execute the processes, because each time someone wants to make an execution, he or she needs to perform a transaction, and everyone needs to re-execute all the transactions in each block to ensure the correctness of the blockchain. And this again brings up to another problem. Number one, when there are a lot of people out there, we can't achieve like a very instantaneous response speed. And this is what they call the transaction per second. So in Ethereum, the transaction per second is only like 15 transactions per second. It's not exactly the best, and people have found out that it is actually not very usable if we are targeting on a global scale. And so right now, there are solutions that were proposed. They are proposed to scale the Ethereum blockchain, and just throw in a bit of names: Stucknet and zkSync. This is what they call the layer 2 rollup solution. And another thing that Ethereum lacks is the transparency, because everyone is able to see everyone's transaction and we execute it in their own local computer. Meaning that, let's say I want to send funds to maybe Ivan, right? Everyone will be able to know that, hey, Chee Chyuan is sending funds to Ivan, and there is no privacy at all. So this is something that we do not want as well. So there has been techniques and have been companies trying to improve on these two, scaling and privacy, to make blockchain in a more usable and to achieve mass adoption. So yeah. So I won't go into detail too much on these roll-up technologies, but if you are interested in, this is a little YouTube link by Finematics. They also have cover a lot of other topics in blockchain. So if you're interested, this is a very, I believe, a beginner-friendly video that introduces you to the scaling and the roll-up solution in the current blockchain space. Yeah. And one thing that we can see now, if you can see at the end of the table, we can see how much it costs to just transfer Ethereum in the current Ethereum blockchain. It's 45 cents. But take this value with a pinch of salt, because this value basically changes with time. It depends on how congested the network is. So when I took this screenshot, it was 45 cents just to transfer money to A to B. And we can see that all these layer 2 roll-up solutions, they are much cheaper. Some even like less than a cent. And it only gets better with a couple of more improvements as being done in a protocol and underlying layer. I won't go into detail as to what are the improvements, but yeah, basically what we can see now is that having this scaling solutions and alternatives allows us to transfer and make transactions in a much cheaper way. And that is another huge step, I believe, in mass adoption. So why cheaper, you may ask? Is because now the network is able to cater for a huge amount of transactions instead of 15 TPS. So we are seeing like 1,000x or maybe 10,000x of transactions per second. And it is for now easily surpasses the capacity that Visa is able to process. Yeah, so this is the story right now that we have. Okay, 10 minutes. I have 5 more minutes. I think should be enough. So okay, so that sums up the current space of blockchain, whereby I talk about we started from Bitcoin and then we go to Ethereum, and now the more interesting part, which is scaling and the future of blockchain. So you may ask, because I know that this is a Golang and Rust team, so I would also encourage all of you to with Rust and Golang knowledge to probably join the space, because there are so many things that that you guys can explore. And how does Rust fits into the space, you may ask? So if you have heard of this blockchain called Cosmos, they are basically primarily a Golang-based blockchain. So a lot of developments there are in Golang, and they are always in constant need of Golang developers. So if you feel that you are interested in getting to know blockchain and you have a decent Golang programming skills, without having to know much about blockchain, you can just apply to any of the company that is involved in the Cosmos ecosystem, and yeah, you probably have a good chance of getting a job. Yeah. And I'm also showing this this little robot thing. It's actually Geth. Geth is known as Go Ethereum. It's a client that runs the Ethereum blockchain. So this client is being maintained and is founded and maintained by the Ethereum Foundation, which is the foundation that oversees a lot of developments and research in the Ethereum space. And they're like and Vitalik is there. So yeah, that speaks a lot. So they are a huge Golang advocator, and in the sense that the entire client is written in Golang. And right now, because it is definitely the first client out there in Ethereum, it has like a massive adoption. So we can imagine that 70% of all the clients that are running Ethereum, it's on Golang. So that alone speaks volume as to how important Golang is in the blockchain space, not only Ethereum but in Cosmos and in many others that I'd like to mention. This logo over here represents Prism. So recently we have the merge whereby the execution layer and the consensus layer has split up. So Golang Geth being the execution layer, and they also have a separate Golang implementation of the consensus layer. So that is also written in Golang. So it only means that Golang is here to stay in the blockchain space. And actually, I don't really know much about Golang. So Rust is something that I know more. Actually, so I give a lot more time to prepare on the Rust slides. So yeah, so where does Rust fit into the blockchain space? So we have this thing called the Web3 Foundation. So if you've heard of this company called Parity, they used to be also an Ethereum node, and they are fully Rust. They love Rust a lot in the sense that I think they're one of the sponsors for the Rust Foundation, and yeah, all of their projects are very Rust based. So Polkadot and Kusama are two of the blockchains that are by them, and they are all Rust-based system. So they also created a lot of toolings in Rust, such as Substrate. Substrate allows you to easily spin out your own blockchain using some of the toolkits that they have, and they are all in Rust. And they also have their own smart contract language called Ink. Ink is a very Rust-based syntax way of writing smart contract in the Substrate ecosystem. And over on the right, we have this thing called Fe. So if you have known of Ethereum, you probably have heard of this language called Solidity. It's a smart contract language that has a very JavaScript syntax it's a very JavaScript syntax like language. And right now, I think it's still in the beta or alpha stage, we have Fe. So Fe, it's supposed to be another option for smart contract developers on the Ethereum EVM space to write your smart contract in a very Rust-like syntax. So if you're interested, go give it a try and go give it a search. You can even do PR on it. The entire repo is in Rust. So there you go. We can see that arguably two of the very big blockchain ecosystem out there are Rust adopters already. So yeah, Rust is also here to stay. Actually, one thing that I really want to emphasize about Rust is that it is not only used in the blockchain space, but it is used a lot in the world of cryptography. So when I mentioned rollups, I failed to mention the upcoming trend with what people call the ZK or validity rollups. So they use a lot of cryptography to perform scaling techniques. And when we mention cryptography, we always think about having a lot of safety, a lot of memory safety, and speed as well. So this is where Rust comes into place. And there is a very neat library called Artworks that has already integrated a lot of those Rust primitives, cryptography primitives in Rust. So that defaults a lot of those teams, such as Mina Protocol, such as Zcash, and a lot of those big teams that are doing cryptography to onboard into Rust. So if you are a very Rust guy and interested in doing cryptography, I always see that people are always looking into hiring Rust dev. And I failed to mention Solana, but Solana is also one of the blockchain companies that's always looking for Rust dev. They don't really care if you do not know much about blockchain, but they are more than happy to train you as long as you have a decent Rust experience. Okay, my time is almost up, but let me quickly finish it. So we have Starknet. They rewrote their entire ecosystem from Python to Rust, and they obtained a 10x speed up just because they rewrote everything. So that again speaks volume. and Foundry, which is a Solidity framework, and it's written in Rust, and it's much faster than HANA app, which is a JS implementation. There's a lot more that I can mention, but I'm going to stop now because I ran out of time, and yeah.
You can I think you can finish it within like few minutes. Yeah, it's okay.
Yeah, okay. I only have one more page left. This is just shilling my eth.kl organization. Yeah, so at the end of the day, I will sum up my presentation with a shameless plug. So I'm from eth.kl, and we are a free and educational community called in Malaysia. So for those who are interested in Ethereum or blockchain in general, feel free to join us in Telegram or Twitter or Discord. So I'm going to leave this up here, and the next will be Q&A. So I'm just going to leave it up here for you in case you are interested to join. Yeah, that's pretty this sums up my presentation. So I guess we have a couple of minutes for questions. Am I right, Evan? Yeah, I can't see the screen, so probably someone needs to.
Yeah, it's good. Yeah, now just questions.
Cool. No questions. I've been super clear, and I'm proud of it.
Question regarding the Foundry and the solidity, and also like no, not solidity, Foundry and
Hard hat.
how was it called? There are two more, like the Near protocol and the.
Oh yeah, so Near protocols are like another type of blockchain that I don't know Near protocol enough, but I think they're using Rust as well. Yeah, probably yeah. So I failed to mention a lot of blockchains out there uses Rust. There are actually tons of them using Rust, which I didn't manage to mention every one of them. Yeah, because there are so many. I just mentioned some of the more famous ones. I guess that's all. If you don't have questions, so I don't know. Should I wait out until my time is over, or should I just pass it on to the next speaker?
Does anyone else have any other questions? Yeah, I guess no one else have questions. So yeah, thank you, Chee Chyuan, for
Thank you.
giving the talk.
Hopefully I'm able to see some of you in the eth.kl group. And yeah, thank you so much, Ivan, for having me, and looking forward to see some of you soon.
Yeah, thanks for joining. And next speaker will be Raj.
Hello, hi everyone. Yeah, can you hear me?
Yeah, can you please share screen?
Sure. Just give me a second, bro. Yeah. Great. Can you see my screen?
Give me a moment. Yeah, can see your screen now. Yeah, I can start, Raj. Raj, are you speaking? I can't hear you just now.
Second. Can you guys hear me?
Yeah, now can hear you, but just now all the while can't hear you. Yeah, you can start.
Okay. All right. Okay, 1 second again.
can't hear you now, I guess. Are you speaking? Raj?
Sorry, can you hear me now? No, or what? Can anyone give me a thumbs up or
I can hear you now, but when you full screen, I can't hear you.
Okay, then I'm not going to go full screen. I'm just going to just just play around with it. Yeah.
Yeah.
Okay. So this is not the MCU I'm talking about. Yeah. So the MCU I'm talking about is basically a microcontroller, and basically a microcontroller unit. So what is a microcontroller unit? It's basically something really small. Right, guys. If you can't see this, let me just make it big. Okay. Can you see the screen? Yeah.
Yeah, I can see the screen, I can hear you.
Cantik, cantik. All right. So it's represented by the micro C symbol. Yeah, it's not UC, it's micro C. So basically, it's a very low powered. So pretty much it runs from 1.8 watts to like 20 watts or so. You can find it in multiple variations, 8, 16 bits, and there's some with 32 bits as well, but it's quite rare. All right. Some of them has one cores, most of them has one cores, but most of them today, the new ones have two cores and above. Yeah. It is switching capability in terms of frequency, so you can run from maybe 1 kilohertz all the way to 133 megahertz. As pretty much three things in there. It has some memory, processors, and some storage. Yeah. So basically, what we have is that we have the SRAM, where your code actually plays around with it and so on. Then we have the EPROM, which is for storage wise, which has some limitations. It's very slow, and after maybe like 300,000 cycles, then the EPROM kind of fails, right? And then we have the flash, which actually has a simple storage for executable code. And it comes in a couple of variations. Yeah, it comes in an ARM chip, it comes in a RISC chip, and some of them, in the old days, we have the x86 chip as well. You still can get it, but it's quite rare. And there are some custom ones as well from China. So yeah. So the popular ones out there are Arduino Atmegas, ESP series, the STM series, the Raspberry Pi Core, and these are the major ones which populating out there. So you can find dozens of them from Microchip, from Texas Instruments, and so on, but they're not very much supported in a sense. Yeah. So what does it have? It has a lot of analog I/Os. It have digital I/Os. It supports what signals like high, low, pull up, pull down, falling, and things like that, right? It also supports some of the popular protocols like I2C, SPI, like Modbus, CAN bus, stuff like that, right? And I2S as well, right? So it's a very good fit for very small applications, and I suppose that it is something that it's it's branching apart from the personal computer scene. Yeah. Well, what's actually an MCU when it comes to industrial and real life purpose, right? So MCU is basically something that you use on is something that you really wanted to control, right? So you use C and you use something bare metal language where you want to control the hardware as much as you can, and you want to have better interaction with hardware, right? But a PLC is pretty much it's fixed. It's very time frame oriented, meaning to say that it does a cycle and then it pauses and it does a cycle again, it pauses, all that. And most of the PLC programming is done by drag and drop and stuff like that, right? So there's no coding, right? And then the popular ones are Alan. I can't remember their name. Day, I think, and Siemens, SCADA, and so on. So those are the popular ones in PLC. We also have Arduino, right, or Mega chips that are somewhat masquerading as PLCs, right? So we are getting into that space right now, industrial space. Okay. The MCU could run in real time for both cores as well. So meaning to say that you can actually run in real time. The programming languages that we use for MCUs are C language, Python, Rust, some of the JavaScript, and so on. Yeah. Popular IDs are Arduino IDE, Tony, Platform IO. Well, Platform IO is actually an add-on to VS Code. Yeah. Cube, Microchips Studio. So these are the popular ones out there. There are quite a lot of things out there, but basically the tool chain is what is important. Yeah. Some of the MCUs have very, very good data sheets. Like Raspberry Pi has one of the best data sheets that I've seen so far in any of the chipsets before.
Okay.
Right? It's best to read these things first, understand what the capabilities are, and then use them. Right? And so what happens with your code? If you write a code in an MCU, you need to cross compile it to a particular architecture, and then that particular code is like a hex code and so on. Then you need to flash it to your MCU. All right, that's the whole idea to that. And it cannot run a full-blown operating system, but it can run somewhat of a real-time OS, which can achieve some level of multitasking. All right. Okay. You ask me what is actually an MCU. 1 second answer will be CPU equals to MCU without any memory management. All right. So if you come in from a very, if you start programming from the 80s and so on, you realize that memory management is really hard. It's really, really hard. And today memory management is taken for granted. So if you want to go back to memory lane, try to make a memory management system in MCU, right? Then you have a lot of applauses from there. Yeah. So modern computers can do a lot of memory management, and MCU don't have memory management. So you got to deal with everything yourself. Right? There's no other way to that. Okay. What is in the MCU? So in the MCU is kind of like miniature CPU in a sense. So you have the oscillator that actually spins cycles and all, right? And then you have the AD converters. You have the microprocessors that pretty much just takes in and out and all that, does what basic things you need to do. You have the RAM, you have the SRAM, and and that's about it. Then you have capabilities. If you look at the image on the right, you have the power module in there, and then you have interrupts, and then you have DT, which is actually the watchdog timer. So watchdog timer is that you can tell the MCU to go to bed, go to sleep, right? And if general usage of the MCU is probably around maybe 20 milliamps and so on, when you go to sleep, it becomes like down to microamps, right? And when it's time to wake up, say after 8 seconds or 1 minute and so on, right, then it will switch it on again, and then with all of the subsystem components on, and then it does, then it goes back to bed again, right, sleep again. So with that variation of current usage, you could average out to a very, very long life battery. Yeah, that's pretty much about the MCU, right? So, but why you want to use the MCU? Right. So the idea of using MCU is that you just want to do one thing and one thing correct. You want to take some form of input, you want to process the input, and you want to come up with an output. All right. You have lots of inputs out there. There's so many peripherals out there, like from gyroscopes to shock resistors to water sensors to GPS and all these things. And you can actually say, okay, if it rains, I want to pull out my drying clothes out there, and that's how it works, right? Basically, that's it. If something happens, do something. That's about it, right? And if you have a bunch of MCUs together, then you have a very good system that is production capable in a sense, right? So it does really good things from there, right? It's actually low powered, it's efficient, it's battery powered to be fair, and it literally, some of the systems can run for more than 10 years or so, right? With just one battery, right? I've seen some projects with one coin cell battery run for 6 years, right? So that's really, really good stuff. Okay, so it's simple to do one task only. It's very easy to replicate or manufacture. So you can actually take some of the open source designs and you can make your own chip yourself. You can change it, and with RISC architectures, a lot easier to do that, right? It's a cheaper alternative than a PC, for example, if you just want to use it for purpose of controlling some things and so on, like a PLC and so on. So it's a lot cheaper. It is literally like close to like, I think, 80 times cheaper than a normal PLC. It has a lot of I/O peripherals to use. You don't really need an OS to run an MCU. You just need a bootloader. So what a bootloader is that it pretty much does some basic stuff in it. I mean, unlike the computer bootloader, the bootloader in the MCU is just slightly different. But essentially it's the same thing, right? So it's just telling us, okay, this is where you start to read the memory, this is what you do, and this is some of the interfaces I declare on, right? You have real-time OS support, and also IoT is the future. So you can have some bots which has cameras built in it. You can have machine learning models built in it that you can do a lot of things from there, right? So one of the examples that you can see is that some of the new cameras out there, which they claim that they have AI built in and so on, actually use this type of MCU, right? So if you look at Arduino ML or Cam ML and so on, right, in a sense, right, you literally see a lot of these things in there. Yeah. Okay. So the next one is
Oh, I should note that you have like 5 more minutes, but you can still extend 10 minutes if you want.
Okay. Sorry about that. Okay, I'll try to make it fast. So there are many types of microprocessors, right? You got the bare metal ones. You have MCUs with built-in Wi-Fi with it, and then you have an MCU with another component in it. Then you have MCUs with another MCU, and you have MCUs with a form factor of another MCU board. Right? So there are many form factors from there, right? So I'm just going to go through very quickly of what we have over here, So this is a bare metal chipset, right? So this is what is powering the Arduino, Uno, and so on. This is the bare metal. You can run the entire application with just chip and power supply. That's all right. Let's go on. And then you have the Raspberry Pi over here, right? So you have the original one over here, and you have the clone ones from Wavemaker. And these are really tiny. It's like 20-cent coin, right? And you have the Arduino Duominolov. This is one of the earlier chips that is actually I think the first 16-bit chip out there, right? And then you have a couple of mini Arduinos. We have the Pro Minis, the Pro Micros, and then the Nano with USB, right? So if you see a lot of the thumb drives that can control your mouse and keyboard is using the Pro Micro system, yeah? Have the STM8 and 32. So these are very, very popular boards for industrial purpose because you have a lot of stuff in there, but it's a little bit harder to program, right? Then you have the ESP32, which is the chip out there in the shielding, right? It has built-in Wi-Fi and Bluetooth, and various flavors and so on. Then you have the another series from ESP32 and 8 mega. If you see over here, we have an ESP. It's not really a Arduino, but it's in the form factor of Arduino. And on the right, you see a combination of two chipsets. We have Arduino chipset as well as ESP together with it. So you get the best of both worlds, right? And then you have bigger one over here. This is mainly used for PLC as well, with Wi-Fi and all of this, fancy stuff in there. And if you say, hey, I want to have an ESP together with the camera, then this is the one you can do. So you can just plug it there somewhere else, and it just runs forever, streaming some videos and so on, right? And then you have expansion boards where you see the nano board on top of another board that actually exposes all the pins, and then you have the Raspberry Pi which have all the pins out there. But if you see the corner, you have the capability to actually run Wi-Fi and Bluetooth as well, right? So that's another chipset in that expansion board. Okay, and these are all ones. You have a wireless communication with XB, and then you have Ethernet together. You can stick it up, and technically it should work, but it's not working this way. So you can have lots of stackable stuff. So there was a joke a long time ago in 2010 where you stack up a lot of boards together, and it still runs. Yeah. So that's the idea of Arduino. You have sensors and inputs. So a typical sensor is temperature and humidity, and then you have some kind of inputs, converters, and so on, where you have IIC converter, where you have a series of data coming in parallel, and then it sends through in a serial format. Yeah. Then you have modules. So what is a module? A module is something that you add on together with it, which is literally what we have over here on the left. Is a relay where you control a different set of current sets. If you want to turn on the fan, heater, and so on, but you have a very small amount of current, you can power up larger currents. And on the right, you have the LoRa chipset, which literally has huge communication gains, up to like a few kilometers and so on. And then these are the programmers. So sometimes when you want to program a chipset which doesn't have an interface, you need to use one of these to actually talk to it. So the famous ones are FTDIs, and you have the ST links from STM and so on to actually program the chip, right? And so basically what you do is you connect to your device, you plug it in properly. In a sense, you use the Arduino IDE. Select the boards, select the libraries you need, write your code, compile your code, test your code and compile your code, and then flash it to your device, right? And then you run it from there. If you want to check some output from it, text output, you can just connect to a UART, and it's like a serial TTY connectivity. You can input output from there, and then it works, right? Some Arduino boards have built-in debug, real-time debugging, which is great. But pros like us don't use that. You have a quick idea of a sample code. So it's going to end very soon. So I just give you a quick understanding how it works here. So the file name is called something.ino, right? It used to be something else. It used to be something else before then, until it's standardized into INO, right? So it's a C program, but if you see, there's no main function over here, right? So what happens is that this particular code has been transpiled into a C code, and then with all the references and all that together, then it's compiled, right? So it makes life a lot easier. Why is it a lot easier? Because you see a lot of macros, a lot of definitions like LED built in, right? For different boards, LED built in is for different pin, different address, right? But because of Arduino, they standardize everything. It makes it a lot easier to use, right? So what is it trying to do is it's trying to say, hey, when you start up, that pin number 2, which is the LED pin, is going to be sending an output signal, right? And then the next thing is going to run is the loop function. So loops is like, while forever, right? And what it does first is I say, okay, for this particular pin, I'm going to set a signal high. So it's going to output 5 volts from it, right? Then the LED is going to be blinking. And then you're going to delay. You're going to sleep for a second. And then you're going to say, oh, okay, I want it. I changed my mind. I want it to turn it off. So you turn it off and you sleep for 1 second. Then it cycles back again in a loop, right? If you press the reset button, then it goes back to the setup function again. So the same code, if you write it in C, it looks like this, all right? So is that you define the CPU speed, which is 16 megahertz, megahertz and so on. You define the delay for 1 second, and then you run in main, right? Because some architectures are using different memory addressing methods. So you have a big Indian, little Indian, and stuff like that. So you got to be very careful on how you address it, right? So what it's trying to say is that, hey, just assign a particular pin for output, and then while it's running in a loop, say, okay, for this particular pin, I'm going to assign this particular value to it, which is high, and then delay for 1 second, and then turn it back low, and then delay for 1 second as well, right? So that's the whole idea from it, right? So that's what it will be doing, and then it will be compiling the code and then make it work from there, okay? And once it's done, all you need to do is just click the arrow button on the right side, and you select the board arrow button, and then there's a tool called AVR Dude. Really cool tool. It does all the fancy stuff for you and so on, and even says thank you when it's done. Yeah. And once it's done, you will see this chipset running, and then it will blink and so on. Right? Okay. So yeah, again, this is all just normal stuff. It's the source code is INO file. The whole project folder is the folder with the source code is your project. So you need to do a lot of copy and pasting stuff over there. There is no library management and so on. There are a lot of files which have the same name, same class files. So you have to be very careful with it. And what I would do is I turn off the verbose output for everything. So some libraries have a lot of functions and variables which are not being used and so on. So it's very important to turn it off as well. And then it's good on what you do from there. All right. So again, why do we use Arduino? Because you have literally just one way to do things, and it could encapsulate and make things work with one single piece of code with all the boards. So what the board manufacturer will do is that they implement a set of Arduino API for that particular board, and they somewhat guarantee that the main functions will work for that, right? So that's the whole idea. It's all about portability. You run from one board, you can have the portability to compile to another board and so on. It's perfect from there, right? It's easy to search. There's a very good community. There's a lot of peripherals with there, with a lot of libraries with it, and it's very easy for beginners. All right. So yeah, so that's pretty much it. I conclude my presentation. But if you guys want to see a quick demo on how I just do it, I could show it to you guys. Do I have time for a minute or so?
Yeah, it's fine.
Sure. Okay. So just
But in the meantime, there are like a couple of questions I'll read it out later.
Okay. So yeah. So what's going to happen is that I run the code and then this whole thing will blink. Right? That's it. Okay, that's the fancy stuff. But I'm just going to show you how it works over here, right? So this is the I'm going to run. I need to share my. Just give me 1 second, right quickly. Camera. So this is the code. This is a chipset, right? And that is the power LED, and then there's a little LED over here or somewhere over here, I think, that will flash once this is running, right? So let me turn this one off. Screen. So basically, it's a very simple thing. I select my board over here and so on. So I can change many things over here. I can change to say that, okay, look, I want certain types of boards. I can select my port. I could, select my processor and so on. So there are many types I can do. I can select even an intermediate program as well, and I can run. So now what I do is that I'm just going to click the upload function. That's all for me. All right. So let me and that's my quick demo. Yeah. So if you guys want to see more stuff and all that, I have a bunch of boards over here. If you want to see a close up and so on, just let me know. Yeah. So yeah. So yeah. Any questions?
There's a question from Conkyung. So MCU have to do memory management by myself. Does that mean I need to malloc and deallocate? Rust allow me to manage memory pointer like C? Question mark. Like a couple of questions in the
no. Okay, it doesn't work that way in a sense. Yes, you can do malloc, but in a very different way. So it's not really directly supported in a sense. The easiest way to do is pretty much just to declare the variable and then leave it. It will pretty much because it's just doing one round, right, and so on. So you don't really need to do much things about it. But you could do a form of malloc, which is implemented in the particular board. Remember, not all the standard C libraries are available to you, and not all the standard C functions are available to you in a sense. So it's not guaranteed to work. But for my experience, you can literally just, for example, if you use a primitive variable, declare it, run it, and then it just takes care by itself, right? The problem is this: you are sharing your memory, you're sharing your flash, you're sharing all of these things, and it does give you give you some weird issues along with it, right? So I wouldn't want to play with the memory management in that sense. Yeah. So yeah, if that's to answer your question, yeah.
And the next question is like, Rust allow me to manage pointer like C?
Yes. It does. Everything that you see in C, it does a lot of what do you call this? The same structure as C correctly. So you don't have to be worrying too much about it. The basic C functionalities and all the keywords actually work over there. So you can expect it to behave the same way as it is. Some things, for example, if you do bit shifting and so on, right, it doesn't really work properly in a sense. So you got to be very careful with it. And accessing pointer memories for some particular boards, they use different types of pointers. So if you get the pointer and you want to access it back, you kind of need to reverse it and then access it back again. So some weird stuff that you need to think about sometimes when you want to deal with the stuff, right? Other than that, most of it, if you follow through the Arduino, it's pretty straightforward. Yeah. So you could do pointers and so on. It works fine, like any C program. No issue with that. Yeah.
Okay, the next question. From the example of the MCU chip, say the Arduino, can I assume they will provide some form of SDK that is Rust friendly, like
It's
for
a
the cross
Rust
compiling and cross linking? You done those?
toolkit, actually, to be fair, right? I have not actually played around with it. I've seen the API and the way how it's done, but I don't really. It's not very friendly to my way of thinking and so on in a sense. But I think some of you guys will be happy to just try it out and so on. The couple of new libraries coming on as well with Rust. I have not actually played around with it, but there are toolkits available. One of the things they do is that they try to use, I think there's a form of LLVM as well, which you can compile it to ELF and then transpile it a particular architecture and so on. So that's possible. So that means you can expose that particular platform to any language that you implements that, right? So I know for some reason, I think I know there's C++ or Rust, one of the implementations use that, right? I'll need to check and get back to you on this.
Yeah, and like one last question. Do you know any MCU brand-wise, model-wise that is Rust friendly?
Friendly.
Yeah, like Rust friendly. Do you know any?
I think the Arduino boards, right? Most of the Arduino boards, like this one over here, right? If you see the chipsets over here, right? You got eth.kl and so on. It actually runs Arduino Rust, right? You all sorry, let me just find out. You have ESP32 that runs Rust as well. So I think a few popular boards already could run Rust. There's no issue. The only problem is that because some of the boards like ESP32s are proprietary, some of the architecture is and registers are not being documented properly in a sense. So you have some issues with that. Even though they call it some form of open source and so on, it's not really, right? So you could use it to a certain point, but if you want to go low level stuff and all that, then it can't really work. So to give you an example, let me just say. So this is a Raspberry Pi, right? So if you use a library that's provided by the Raspberry Pi, you could do really cool stuff with it, right? That means the Raspberry Pi C and so on. But if you use Arduino version of it, then some of the functionalities are not there, right? So that's a problem to it. And there's just no way to go back from this. It's just one weird thing we got to deal with, right? So the same thing goes with Rust. So you could do Rust, but it's just a wrapper on top of the actual documentation that you have right now, right? Or the bootloader that you have right now. Yeah.
I thought you haven't tried it out, but sounds like you tried it out.
I tried a little bit to a point, but not really good enough for me to say that it's working properly or not. Yeah.
But you tried something like Hello World already, did?
I tried the toolchain. The toolchain works. It's good. The API kind of not really my type of API and so on. So it's very like very object oriented API. You know what I mean. So that kind of way is not really friendly for programming in that sense. Yeah. So you want to have the flexibility to change things in definition and so on, right? So if you're a C programmer, then you want to be very flexible so you can port your codes and all that, but it doesn't really work with Rust. Yeah.
Is it straightforward to get started with Hello World for embedded in Rust compared to C?
Easier with Arduino, a lot easier. I think tooling will get better in Rust soon, but Arduino is a lot easy. So just to let you know that both pretty much, both require some form of setup, right? But Arduino is a lot better to do, a lot easier to do. So all you need to do is just download the IDE, and it works. That's it. Nothing else to do. All right. But if you want to do Rust, then you got to install some libraries, some applications, the toolchain, the compilers, and so on. If you don't have them, and then once you do that, you compile it. Then you still have to flash it as well. Then you got to use one of those flashing tools for that particular board, and then you got to see which one works, and then make it work from there. So it's not a very straightforward process, but I think in time to come, it will be a lot easier to use. Yeah.
Okay. I guess there are no more questions. Thanks a lot, Rush.
Hey man, for your time, appreciate it.
Thank you. Yeah, now for the next speaker will be Alan.
Okay, hello, how are you? How many people we
Yeah.
have here today? 1, 2, 3.
Now there's like fewer, like
There's quite a few.
around
guys.
13, 14. Yeah, I think you
Yeah.
can. Do you have slides? Do you want to share your screen?
Yes, let me see if I can just share. Oh, this is crazy. I have to give it permission. Okay, give me a second. All right, 1 sec, let me rejoin.
Hey, Alan is back.
Oh, cool, and I was automatically joined. How do I go to the view? See, let me share my screen. Here we go.
Can't see your video yet. Yeah, now
Yep.
now we can see.
There we Man, I don't think I've ever played too much with this, so I'm learning everything right now. Cool. So you can see my screen. Yeah, again, I just want to apologize to everybody because I haven't been able to join. I was supposed to come on here, I think the last meetup, and was crazy busy, and now I'm still crazy busy. So my presentation is all about that's weird. Stream's still running. Okay, so I think that's really weird. You cannot keep it going if I go back to hit the button. Can you guys still see my screen or no?
We can only see Rust with Flutter, Alan.
Okay. All right. Weird. Yeah, because this says it's stream's still running. Okay, cool. Yeah. So obviously I'm here to talk about Rust and Flutter. I guess everybody's heard of Rust, but has anybody not heard of Flutter before? Maybe you can thumb up or something if you haven't heard of it. So you have not heard of it. Okay. Anyways, I want to talk about my background, right? So you guys have probably heard me, maybe you've heard me before, but let me just go over my background. So I started programming professionally when I'm about 2008, I believe, right when I graduated, and started off doing Ruby, moved on to Elixir, and within the last couple of years started doing some Flutter work. I finally started getting into Rust in 2020, probably much later than I think most of you guys. And to kind of give back to the community and get more into Rust, I started doing podcasting. So I do a lot of episodes on my station. Basically, every Friday I release an episode. So if you haven't, go ahead and check out the podcast. I try to interview up and coming people or even well-known people within the community. Yeah, otherwise, besides that, I'm actually working on 3 podcasts. So I have another podcast all about Flutter and another podcast I do all about Elixir. And so I'm basically working on those 3 different technologies, mostly Elixir and Flutter, very little Rust. But I've been hoping to change that soon. And I also do my own consulting company within Hong Kong. So I'm coming from Hong Kong right now. So another question may be, why Rust? I don't think I have to tell you guys, but we can go over that. I've always been fascinated with writing kind of bare metal code. When I mean bare metal, of course, no GC, no VM, just straight to the hardware as much as possible. I've always been a little bit nervous about doing that because there's a lot of pitfalls when you write C, C++, which is basically, of course, the most well-known kind of bare metal programming languages, as you may call them. And the multi-platform support is great, right? Even they have great WASM support because of like obviously the history of Rust and with being part of Mozilla. Memory safety and the fact that Linus is letting it into Linux is huge. So that already leaves a lot of credence to it. Now, why Flutter? So I think you've all heard of Flutter before. I don't know if anybody has anybody not programmed in Flutter before?
I think probably most of them haven't heard about Flutter here.
Well, I don't know. I was hoping to hear some feedback. I'd like to, if you guys could feel free to speak up. I feel like all by myself, I'm just talking. So, yeah, I mean, Flutter is is basically a framework all about building the UI. So whenever you guys make an app, usually people will judge your app based on how it looks. So this is always something that has been important to me. I think all of us, I think we're all pretty much hardcore nerds. We just kind of work on the code, make sure the code is good quality, make sure it runs fast, etc. But normal people really cared, how does it look? If it looks good, it must be good. If it looks like shit, it must be shit. I apologize if that's not a good word to use, but that's a lot of people will think that way. And so Flutter came onto the scene. I kind of dismissed it right away until I decided to play around with it because I had a client who wanted to have a mobile app. And I gave it a try. And for somebody, just to give you guys a background, I can't even draw a stick figure. Let alone, I cannot even write Chinese. Like I can write it, but nobody can read it. Even my English writing is quite horrible. But also my CSS skills are not very good either. It's okay, you can laugh at me. I don't mind. I'm used to it. But my CSS skills are not very good either. But what I did find that when I was using Flutter, I could basically make anything I wanted to make because of the way that Flutter actually works. It's basically a composition kind of form, so you can start composing what they're called widgets together. So if you ever work with React, think about composing components together. In this case, they're called widgets. And you may be asking, what's a widget? Well, that's a long story, but in short, everything is a widget once you get into Flutter. I may be able to come back and kind of do a little bit more hands-on demo in the future in case you guys are interested more in Flutter to see how it works. But anyways, what was kind of nice about Flutter 2 is the way it all works is because you're actually writing in code. You're not writing in some XML format like Android used to be, or I think it still is, unless you use Jetpack Compose. They also have this thing called hot code reload, which is not, it's not in a language like Rust, but Dart actually supports it out of the box. And so Flutter just builds upon that, uses Dart's native ability to do this kind of thing. And what I didn't talk about is that Flutter uses a programming language called Dart, which if you haven't heard of Dart before, you may have heard the blowback that happened quite a few years ago, where Google wanted to include a native VM into Chrome all about Dart. It's kind of an interesting story, but in the end, Dart is actually a language that's made to replace JavaScript, but it didn't end up happening. Obviously, we don't have a Dart VM in our Chrome browser, and everybody's still writing JavaScript. But you can see, if you start playing around with Dart, you can see it's a nice mixture of Java and JavaScript. And for me, I don't like Java, and I really hate JavaScript, but I find Dart to be a pretty pleasant experience. But in any case, hot code reload's really cool because when I started working on mobile apps quite a few years ago, I did it natively, even with Objective-C, way before Swift. And I always found that I would be writing something, press play to start the app, and right before it compiled, I would say, oh crap, I forgot this, I had to stop it. Basically, as soon as you're done making changes, as soon as you save, it's already there on your screen. Before you even lift your finger off the key, it's already up on the screen, so you can see your changes right away. And it helps because when you're working with a UI, you have to be very precise. So having this kind of ability is super, super useful. The other thing too is it's already capable of 60 FPS, even up to 120, and maybe probably even more than that. Just depends on how fast the device is. But 60 FPS is definitely easy for it to do, depending upon how you write your code. But in general, the framework can do that. The cool thing too is that there's also a lot of plugins. So basically anything you can think of, they probably already have a plugin for it, whether it's iOS, Android. Now they do Mac OS, Windows, Linux, and Web too. And also Toyota's actually using it for the new infotainment system. And a couple other people are also using it for different things too. So those are kind of the big platforms that they support. But you can basically port this to nearly any other platform that you want. And I did write on here, you can see on my slide, multi-platform, not cross-platform. I want to talk about this one because it's quite important. So when you think about cross-platform, at least when I think about cross-platform, I usually means like a web browser and you have something that's showing there and you click on it. It usually looks horrible and not a good experience. But this one truly compiles down to native code. So I did talk about how Dart was a language made to replace JavaScript. And it just so happens that they actually made it also compile to native code. So when you write an app for whatever and you actually write it to something called release mode, it'll compile down to native code to that particular platform. So there's no like web browser or kind of subpar experience. It's really, really fast and it is native. It's a native app out of the box. That's something that just doesn't happen for a lot of apps. Is there any questions about Flutter or I should move on?
Yeah, I can move on.
Okay. Now maybe you're wondering, why not just do something totally in Rust? There's Slint, which they have their own template language. I feel like that's a little bit not so much fun to learn, but maybe that's up your alley. For me, I prefer kind of writing in all the same code, kind of having everything all together. eGUI is kind of cool too, but it's not so flexible as you can do with Flutter. GTK, I haven't tried it myself, but it still has C and C++ plus under the hood as far as I know. Same with IUI. There's Tori, but Tori they also use a web experience. So you still have to write JavaScript, etc. And there's ICE, which I haven't tried yet either, but I think it's being used in was it System 76's OS. So it should be pretty decent, but I don't know too much about it. If there's any others that I've skipped, let me know. That's important. But these are ones who I consider to be kind of up there for, could be used. So maybe out of all these, maybe ICE would be the most interesting for me. Now, what's the benefit of using Rust and Flutter together? Well, as I said before, you get true multi-platform support because Rust can compile to basically nearly any architecture and OS, along with Flutter. Well, at least for the major ones, which I think most of us will be using, of course, unless you're writing something very specific, but you can still port this over. And Rust has got a lot of high performance packages that could be used. You just need to write a little wrapper around it. And I think that Flutter's GUI system, the way it all works, is super awesome and very flexible. And yeah, it makes writing GUIs very simple and easy and fast, especially with the hot code reload. So I think putting these two different technologies together, you can really get the benefits of performance from Rust, along with a super fast and highly efficient GUI from Flutter. And that's the end of my presentation. So you can feel free to connect with me to talk more about this. I have a course at rustwithflutter.com to kind of talk about how you can combine the two, in case you're interested. And if you're interested more about Flutter, I have another podcast called Flying High with Flutter, where I talk all about Flutter. And that's it.
Does the Rust compile time impact the Flutter integration? Because like you say, Flutter have like hot reload.
Yes. I mean, either one. When you compile, so no matter what you compile, right, you're going to have it's going to take time, right? And if you compile in release mode, it's going to take more time than development mode. Maybe to kind of talk a little bit more about how Flutter works when you're developing locally on your machine. You're just in development mode. It's what actually happens is that they ship a VM to your device, and you just push bytecode to it, and it just updates up by itself. So that's how you get the hot code reload working. If you have release mode where you compile your app to a release mode, you don't have the VM anymore. So actually, you're going to have a native compiled app. It'll be much faster, but you don't have the hot code reload. So that's kind of like you develop with the development mode, and obviously you release the release mode. I'm not sure if that answers your question.
Yeah. Is there any other question? I think someone is typing. Yeah, so the question is, so that transpiles to JavaScript for the web, but compiles to native for like iOS and Android?
Yes. So what happens is that it can compile to whatever target you kind of give it, and it works with those libraries. I need to dig more into. I was trying to dig more into how exactly that part works, but what I do know is that they do use the native libraries and whatever you have on your machine to get that happen, to actually make that happen. So obviously, if you don't have iOS SDK on your machine, you cannot compile to iOS. But they have something like that, and there's going to be some things that they ship with it. So Dart is a garbage collected language. There's a garbage collector, so actually it'll compile and have that garbage collection piece on your machine. Whatever that thing is that you're compiling to. But yeah, it does transpile to JavaScript and compiles natively to iOS and Android.
Do you interface with the Flutter code from Rust using like using Rust like a C library or something? How do you do it?
Okay, so originally, this is a great question. So originally, what would actually happen was that you had to call out to the native code, and the native code itself would talk to. When I say native code, I mean like, okay, you would ask the platform through something called a platform channel, and it's basically sending a message down like a wire, kind of like a what do you call that? Kind of like a WebSocket or a socket of some sort, where you'd send a message, and then send messages can come back, and you would talk that way. And what you would do is you'd have to write your native extension directly to, say, like Swift. So you'd send a message from platform channel from Dart code down to Swift. Swift would then call the native code and then back that way. Now, since a couple versions of Flutter and Dart a while ago, you can actually talk directly straight to the native code itself. So there's actually a native FFI already in Dart itself. So you can skip that platform-specific language.
Okay, and there's another question by Whipslander. Look into Flutter, but I found you to be more powerful. Is there a reason why we should use Flutter when Wasm PWA can be faster, etc.?
That's a great question. If you're going to go for web, I wouldn't recommend Flutter. You can do it, but even as you say, it could be slower, right? And the web support is not that great. I did mention one of the greatest strengths of Flutter is having hot code reload, but there actually is no hot code reload when you're working in web. It's actually recommended that you build everything for, like, if you're running on a Mac, you run everything on a Mac and then compile it to Windows or compile it to web, etc., or the other way around with like Windows, etc. But when you're going to have a web, I wouldn't recommend it. I think there's much better technology. So yeah, I mean, maybe U does make more sense for you. If you're going to be doing an app where, say, you're only writing for a specific platform, it usually makes more sense to go for that direct platform. But if it doesn't really matter, say maybe you might switch to another platform later on, or there's nothing very specific about your code and you're already very familiar with Flutter, then it doesn't make it makes sense to still work only in Flutter. Like, I don't know how many guys actually try to make your own mobile app, but I've like my Android apps look like Android apps, my iOS apps look like iOS apps. But when I use Flutter, I can make it truly like unique. I'm not sure if that answers the question exactly, but I this is how I would justify it. Maybe I rambled on too much.
Okay, there's last question by Kon Kyung. When you mention Rust and Flutter, is it Rust as base with main calling and invoking Flutter function to do like something, or like draw display widget in the question? I'm not sure how to talk about this. And then also, or is it like the Flutter app that will invoke call Rust function as a form of Wasm? Like, so which is the base?
Okay, that's a great question. I didn't make that part clear, and that's fine. What I recommend is you write a Flutter app, and then you call native FFI functions for what you need. To be honest, when you cross that FFI bridge, no matter what language you're doing, there's going to be some penalty for that. So I recommend all of your like heavy or very Rust specific stuff you write in some kind of FFI way, and then connect it. I haven't seen somebody ever call Flutter using Rust. I'm sure there must be a way to do it, but I would recommend you go from Flutter calling into Rust, not Rust calling into Flutter and drawing widgets, etc.
Okay, I guess that's all. Thank you, Alan. So now, thanks for the talk. So now let's conclude the conclude the meetup. So I haven't give a good introduction yet. So we are Rust Meetup Malaysia. We do meetup because the time just now is like very rush. So we just start and we do meetups every 2 months. So every 2 months, Wednesday night. So this will be the last. Today will be the last online meetup, and so I decided to like just accept multiple like lightning talks and invited speakers from around the world. And so the next meetup will be in Malaysia, like Kuala Lumpur. So we haven't decided the venue yet. We are still looking for the venue, and we are still looking for speakers. So thanks a lot for joining, everyone. So now we will end the YouTube live stream. And for those that want to hang out, that you can still hang out around here. We can discuss